Hello everybody, hopefully you're all doing okay today, and today we shall be doing differentiation by the power rule. Now for most of you, you'll just know this as just standard normal differentiation, and basically what it is that when y is equal to x to the power of n, then dy dx, which is the gradient function, will equal n times x to the power of n to the minus 1. And we can actually prove this. So if you remember differentiation by first principles, I've made a video on that. You may have done it before, so hopefully you do. If not, feel free to check out my video to understand it if that's an area you need to work on. Anyway, if we have f of x equals x to the n, then the differential equation f dash of x will equal f x plus h minus f of x all over h. That is what we remember, with limits as h tends towards 0. So that is differentiation by first principles. So in this case, we're going to have this equal to x plus h all to the power of n minus x to the power of n over h. Now obviously n could be any number, so this could go on forever. So if we just put equals limits, which I often forget, you shouldn't though, so don't take me as prime example. Right, our first term will be x to the n, then we'll get binomial expansion. So hopefully, if you've done binomial expansion, you'll understand what I'm doing here. That's just a number, the n, c, and the 1. Right, so then we're going to get plus cn2 times x to the n minus 2 times h squared, and this will go on and on, possibly forever, depends how many n terms there are, or what number n is even, and then plus hn minus x to the n. Minus x to the n is of course from this bit here, which is just our f of x function, and this is of course all over h. So we've got a bunch of h's here, so this will equal limits h tends towards 0, we'll get cn1, of course x to the n there and x to the n there will cancel off, so we needn't worry about those. So we're going to get that times x to the n minus 1, h cancel off from dividing, then we'll get plus cn2 x to the n minus 2 times h, and all the way plus dot dot dot, as it goes on possibly forever, h to the n minus 1. We've got h to the n divided by h, and as h tends towards 0, this leaves us with n x to the n minus 1. And if you have done binomial expansion, then you'll know that with the c and whenever it's the first term, it's always just going to be equal to whatever n happens to be, which in this case is just n. So let's try our first example, shall we? Right. Differentiate y equals minus 4x. Okay then, so y equal to minus 4x, which means dy dx is going to equal, so if you remember the power rule, we times by the n, which is right here, which in this case is 1, it's x to the power of 1. So we times by that, so there's going to be 1 times minus 4x, and then we do n minus 1 for the powers. So that's going to be a 1 minus 1, which is 0, which just anything to the power of 0 is, well, almost anything, is 1. So we're left with minus 4. So not too hard. Hopefully you followed that. Right, next example is to differentiate x squared plus 7. Right, well, this is getting a tad more complicated. So we've got y is equal to x squared plus 7, and we need to find dy dx. So if you'd like to have a go, feel free to pause the video and have a crack at it yourself, now that you've seen an example and what the rule is. So please feel free. Right, now let's have a crack at it ourselves. Dy dx is going to equal 2 times x to the 2 minus 1 plus, well, there's 7 here. That is x to the power of 0. So that means we're going to times by 0, and, well, that's just 0, so that needn't be considered. And this, of course, will just equal 2 times x to the power of 1, 2x. See, very, very not complicated. So let's try a slightly more advanced example, shall we? So, find the gradient of the tangent of f of x equals 2x cubed plus x plus 7 at the point at which x equals 7. Now, if you have seen my differentiation by first principles video, this was the top example, the very last one, I do believe, supposedly the hardest of the bunch. And about as hard as you should expect with those, certainly not as hard as you should expect with the power rule, as you shall later see. So, f of x is equal to 2x cubed plus x plus 7. So if you'd like to have a go at this yourself, please pause the video now, have a crack at it. Hopefully you get it all correct. If not, that's fine. We'll go through it in a moment and explain any possible worries or anything that went wrong. Right, so first we want to differentiate it. So that means that f dash of x is going to equal 3 times 2x to the 2, 3 minus 1, plus 1. 7 will cancel off, as do any non-x term numbers. So if you ever see those, don't worry about them. Right, and x will just become 1 in this case because there's no a in front of our x, and there's, well, it's not a particularly high power, so just 1. Right, and this equals 6x squared plus 1, and at x equals 7, f dash of x will equal 6 times 7 squared, so it's 49, plus 1, which equals 294 plus 1, which is 295. Hopefully you got that as well. If not, hopefully you saw where you may or may not have gone wrong. So let's have a look at our next example. This is seeming not too hard, isn't it? Hopefully. Might just ignore that bit there. We have to differentiate y equals x plus 7 times x minus 2. So if you'd like to have a crack at it, pause now and do. And if not, well, I'm going to go through it right now. Right. So if you're thinking to differentiate this, you can just get 1 plus 0 times 1 minus 0. Well, that is incorrect. First, we must expand. So y equals x plus 7 and x minus 2. So if we expand these brackets out, we're going to get x squared, of course, plus 7 minus 2, 5x, and minus 2 times 7 is minus 14, which means if we are to differentiate y, so to find y prime, y dash, we'll get 2 times x to the power of 2 minus 1, so that's just 2x, plus 5. Well, there we go then. That was a handy-dandy example. Let's try this one on for size, shall we? Find the second derivative of y equals 4 times root x over x to the power of 5. Right, so you should hopefully know your indices by this point, which will be imperative in answering this question. If you'd like to have a go, please do so right now, and hopefully you get it right. Right, let's have a look, shall we? Y equals 4 times x to the power of a half, that's what a root is, all over x to the power of 5. So that means we can take the 4 out. Well, we, like I said, need to focus on the 4, just need to focus on the x's. So a half of the 5 down here for the power of x is going to be going into taking away the half up here, which means we will be left with 4 over, which means the x to the power of a half will cancel off, over x to the power of 9 over 2, which is 5 minus a half, 4.5. So, and then if you continue to remember your indices, that means we have 4x to the minus 9 over 2, because when you have x to the minus 1, it's 1 over. So when you have 4 over x to the power of 9 over 2, it's just going to be a minus right there. And now we can differentiate. So if you had a trouble with that beginning bit, if you'd like to have a go, feel free. But I am going to go through it right away. Right. dy dx equals minus 9 over 2 times 4 times x to the power of minus 9 over 2 minus 1, which is going to equal the 4 and the 2 will cancel off, which means you just got 2 times minus 9, which means you have minus 18 on top, and that's times x to the power of minus 11 over 2. Now you're probably thinking, well, jolly good, I have bested this question, but no, it says second derivative, which means we must differentiate again. So we're going to have d squared y over dx squared to equal minus 11 over 2 times minus 18, which is 99, positive 99, minuses cancel off, and then we're going to have minus 11 over 2 minus 1, which gives us x to the power of minus 13 over 2. And that right there is your second derivative. That is the question done. Right. Hopefully you followed all of that. And on with the next question, I suppose. Bring it on. Find the value of x for which dy dx is equal to 5 when y equals x cubed minus 7x plus 1. Well, that seems like an absolutely astounding question. Let's have a look. So if you'd like to pause the video, feel free to have a go. Who knows, maybe you'll figure it out in your head. Either way, I'm going to go through it now and make sense of it. Right. So we're going to go with f of x, because y f of x matters not. I mean, I suppose I should keep it as y, because they gave it as y. But I felt like going for something a little different from the previous examples. So x cubed minus 7x plus 1. So f dash of x is going to equal 3x squared minus 7. And we want to find it when it equals 5. So if we do some handy-dandy rearranging, we have some 3x squared equals 12, x squared equals 4, and x equals, hopefully you figured it out, maybe you guessed it off the top of your head, plus or minus 2. And you can actually represent this on a graph per se. So if you have your axes right here, 3x squared minus 7, well, that is an x squared graph. You needn't worry about the roots. We're just trying to find when dy dx equals 5, which means we're looking at the gradient function, so it needn't show that on our graph. And we've determined it's at the point where x equals plus or minus 2, so there's plus 2. It's not a good graph. There's minus 2. If I had drawn an accurate graph, you'd actually see these are in line with each other. They'd have the same y value. However, I didn't draw it particularly well, but, well, it matters not. It's just a representation to try and help you understand. Right, have a few more examples to go. Well, on to our last couple of examples now. Find the derivative of the function f of x equals x times root x plus x, 3x squared minus 4x to the power of 5, that is, plus 2 all over x to the power of 5. Good Lord, that is a question and a half. Well, who's going to take it on? We are. So if you'd like to pause the video, feel free, have a crack at it. Hopefully you get it all correct. If not, that's fine. I shall go through in a second. And, well, good luck. Right, so we need to simplify this down, as we established earlier in one of our questions. So we have f of x is equal to x times root x, x to the power of a half, plus 3x squared minus 4x to the power of 5 plus 2 all over x to the power of 5. So x times x to the half, that's going to become x to the 3 over 2. So we'll write this out. We'll have x to the power of 3 over 2 plus 3x squared minus 4x to the power of 5 plus 2 all over x to the power of 5. And now we can simplify it down further. So we have 1.5 and 5 here, so 1.5 of this 5 is going to go into that 1.5 there, which means we're going to get this to equal x to the minus 7 over 2 plus 3x to the minus 3 minus 4 plus 2x to the minus 5. Well, that is quite a function. Now we can differentiate it. So f dash of x is going to equal minus 7 over 2 times x to the minus 9 over 2 minus 9x to the minus 4 and minus 10x to the minus 6. Right. That is quite something to work with. So this is going to equal minus 7 over 2x to the 9 over 2 minus 9 over x to the power of 4 and minus 10 over x to the power of 6. Two ways of writing it. Because the minuses mean that it's on the bottom, and it doesn't really matter which way you write it. I'd put this x up here with a minus 7. But then with the minus, I'd probably go with this one, just because it seems fully simplified. So, that was fun. Shall we have another example to go through? This one is quite a smashing question. Find the range of x values for which the function f of x equals x cubed minus 6x squared plus 9x plus 2 is decreasing, but the gradient is increasing. Well. Something that you should know, in case you didn't already know, is that a function is decreasing when it's below the x-axis. So when you look at this, it's got a cubed as the highest power, so it's going to become an x squared graph. So if you imagine your x squared u, that would be, and this is your x line, x-axis, that would be where the part of the graph is below the x-axis, which is usually below the roots. Unless it only has one repeating root, in which case, well, you're a little bit scuppered, because it's the f of x function isn't decreasing. But if the gradient is increasing, that will be when f dash dash of x is greater than 0. So hopefully you'll see as I go through it, or vice versa, you may prefer to actually have a crack at this yourself. So please do, if you'd like to. And if not, well, that's jolly good, because I'm about to go through it. Now, f of x equals x cubed minus 6x squared plus 9x plus 2. Now, we don't need to do any simplifying here, so we can just right away establish that f dash of x is equal to 3x squared minus 12x plus 9 from differentiating this right here. And we need to satisfy what the question is asking is when our gradient function is less than 0. So this, if you look, will in fact factorize. So let's factorize it. 3x minus 9 x minus 1. Yes, that seems right. Less than 0. So that means we need to get it below the axis, which means when it's less than 0. For an x squared graph, like I said, that's when you have your x line. Let's say this is your curve. It's going to be below here, which means it will be, x will be less than the largest root and greater than the smaller root. So x is less than 3, but x is also greater than 1. So for the gradient function part of this question, 1 is less than x, which is less than 3. And that is this section here. Now we need to find gradient is increasing. So gradient is increasing when f dash dash of x, so that will be your d squared y over dx squared, is greater than 0. So let's differentiate this. 3x squared will become 6x, and it will be minus 12 greater than 0. 6x greater than 12, which means x is greater than 2. Therefore, if we couple these things together, that's just therefore in case you hadn't seen it before, 2 is less than x, which is less than 3, and that is our range of x values for which this question is in fact satisfied. And you're probably thinking, what is this in graph terms? It's actually right here, the turning point of the x squared graph. X at this point equals 2. So if you look at our gradient function of 3x squared minus 12x plus 9, you can complete the square on this. This is the other way of finding 2 right here. You can complete the square, which you may already know. If you're doing differentiation, I imagine a lot of you will. So first we must take out the 3, right? And then that will leave us with x squared minus 4x plus 3. Then we can start completing the square on it. So that equals 3, another bracket, x minus 2 squared minus 1. Which means the turning point of this is 2 minus 3. So that's where our 2 came from. So the turning point, if the question wanted that as well, is positive 2, negative 3, because we times that out. We don't times inside the bracket, and that will always, you always put a negative sign in front of that, which means in this case negative will give us a positive 2. And well, that wholeheartedly is differentiation by the workings of the power rule. So hopefully you understood everything. If not, feel free to replay parts of the video, parts which you feel is necessary to have a look at again. If I did make any mistakes, which is possible, please let me know down in the comments, or if there's anything you didn't follow. And otherwise, well, cheerio.